Okay, this is your review video for the Unit 4A test review. It's going to be kind of long, so remember to make sure that you do chunk it and just do a little bit at a time. I don't expect you to do the whole thing at once. So first of all, it says number 1, find the volume of each shape below. This is for numbers 1, 2, 3, and 4. So remember, when we're finding volume, all of our volume formulas are area of the base times the height of whatever prism you're looking at, or in this case, a cylinder. A cylinder is prism-like. So right here, when I'm looking at this, I have a circle, so the base is going to be pi r squared. That's my area of a circle, and then times the height. So if you were actually using your formula sheet, this is the formula that you see on the formula sheet. When we plug in all of our numbers, we get 3.14. Remember to use 3.14 for pi, times 7, times 7, times 7, times 10. And remember, you might want to go ahead and do this, that r was equal to 7 because the d was equal to 14, just to make sure you have both of those. When you do all the math, you wind up with 1538.6, and this is kilometers cubed. So this is our answer here. Make sure you are showing me the formula you're using and plugging in your numbers so I can see how you're doing the problem. Okay, number 2 is the same thing. It's still going to be the area of the base times the height, but remember, because it comes to this point right here at the top, this is meaning that we have it, well, obviously we have a pyramid, but we have to remember we don't need all of it, we only need 1/3 of it. So it's still area of the base times the height, but it's going to be 1/3 area of the base times the height. So when I do this math, I'm going to wind up with 1/3 times 11 times 11 times 7. And after I do all that, okay, remember that this is, when I do all the math, what I've done is 11 times 11 times 7, and then I divide it by 3. Makes it a little bit easier when you're typing it in a calculator. So we wind up with 282.3 meters cubed. And again, remember, volume is always in our cubed units. Also remember, on this shape, this is considered a square pyramid because of the fact that the base right here is a square. So we have to make sure we know how to label this. This one here is going to be a triangular prism because we have a triangle on the bottom. So again, volume is equal to the area of the base times the height. If we can remember that, pretty much we can remember everything else. So then we have volume is equal to, and again, the base is a triangle, so it's half BH times the height of the entire prism. When I plug in my numbers, I get half times 3 times 4 times 9. And when I do all that math, we wind up with 54 miles cubed. That's our volume on the the triangular prism. The next one is a cone. So again, if I had to label this as a cone, it's not a circular pyramid, it's just a cone. And again, because it does come to this point at the top, we have to do 1/3. So it's 1/3 the area of the base times the height. So make sure you're remembering just that 1/3 part because it comes to the point. Again, when I plug in my numbers, I get 1/3. The base is a circle, so it's 3.14. And again, R is 9 and D is 18. So it's 1/3, 3.14 times 9 times 9, because that's my 9 squared, but again, easier to write it out. So when you type it in the calculator, you do it right. And then times 18 for the height of the cone. When I do all that math, again, multiplying all this in my calculator and then dividing by 3. When I do all that, I get I'm going to write it over here, 1526.04 inches cubed. There's the volume of that cone. Okay, next page, we're finding surface area. Remember, surface area gets a little trickier because there's a little bit more work. Again, if you want to use the formulas, you can, but I'm going to show this to you using the way I taught you in class. So clearly on my cylinder here for number 5, I have 2 circles. And so the formula to find the area of a circle is pi r squared, but since I have 2 of them, I'm going to alter my formula and say 2 pi r squared. When I plug in my numbers, I get 2 times 3.14. There's my pi. My radius is 10, and another 10 because it's 10 squared. When I do all that math, I wind up with 628 kilometers squared. Now that is for only my 2 circles. I meant to circle that. Now I also have, remember, what I kind of call the label. So if I'm looking at my label on my soup can, which would come off of this curved part, remember the top part here is the circumference of the circle. Circumference is pi d, and then this is the height of the label itself, which is going to be 8. When I do this math, so my label is going to wind up being 3.14 times the diameter, which is 20, times the height, which is 8. And when I do this math, I come up with 502.4. And now I have to add these two together to get my total surface area, which winds up being 1130.4 kilometers squared. Remember, it is back to area. So area, even though it says surface, it's still area, so area is squared. Number 6, we have a triangular prism. Just because it looks like it's sitting on that rectangle, remember it still is a triangle, which means I have 2 triangles to start with. The 2 triangles are going to be 2 times half BH. That's going to be my formula. Now, the thing is, the 2 and the half actually cancel each other out. That becomes 1. So, in essence, all I'm really doing is taking the base times the height. And when I do that, it's 3 times 4, which is equal to 12. So this is the area of my 2 triangles. Then I have 3 different rectangles that I have to do here. The first rectangle is going to be 3 by 4, which is 12. My second rectangle is 5 by 3, which is equal to 15. And my third rectangle is 3 by 3, which is equal to 9. When I add all these up, I wind up with 36. And again, I'm adding these 2 things together. So my surface area is 48 feet squared. Make sure you have your proper units when you're doing this too. All right, we have a cone again, and we have to find surface area. This is actually the one formula that you're kind of using straight off of your formula sheet, but we also broke it down still. We know we start with a circle, so my circle is still going to be pi r squared, which means 3.14, and the radius here is 8 times 8. When I do that math, I wind up with 200.96. So this is just for my circle. We also know that this top part here, that when we wrapped it around the circle, and it became all of this around the circle, when we flatten it out, we talked about it being a Pac-Man. Okay, so then I said I need to find the area of Pac-Man. So to find the area of Pac-Man, it's pi r L, which is that weird L, which means slant height. So again, pi 3.14 times the radius is 8, and the slant height here is this number right there. It's not the height here that would be if they had a number there. We don't have a number this time, but if they gave me that, it's not that number. It's the slant height that's this right here, which is 17.9. And when I do all that math, I wind up with 449.648. And again, both of these need to be added together. And when I add them up, I wind up with 650.608 miles squared. And again, area is always in our square units. Okay, this one here is a square pyramid. Since it's a square on the bottom, that part's easy. We're going to find the area of a square, length times width, which is going to be 8 times 8, which is going to equal 64. So that part there is really easy. The next thing we have is our triangles. And we actually have 4 triangles that are all the same because of the fact that all the bases of the triangle are 8, and all the heights, which is the slant height, all the heights of the triangles are 9.8. So it's going to be 8 times 9.8. Actually, wait, sorry, half that, because we need half base times height. So when we do that, we wind, and also we're going to times it by 4. So when we do all that math, half times 8 times 9.8 times 4, when we do all that, we wind up with 156.8. So again, this and this get added together, and then my surface area, I'm going to write it down here, my surface area winds up being 220.8 kilometers squared. So that's my surface area of, again, a square pyramid. All right, now we're doing total area and perimeter for the composite figures. So on this one, I'm going to start off with this semicircle. I know that to find the circle, to find a whole circle, it's going to be pi r squared. But I only need half of it, so I'm going to divide it by 2. When I do that math, I have 3.14 times the radius was 4.5, and again it's squared, so I'm going to put 4.5 again. Remember, writing it out like this makes it a little bit easier on your calculator or when you're typing it in to get the math. And I'm dividing the whole thing by 2 because I only need half of it. So when I do that math, I wind up with 31.7925. So this is my semicircle right here. Then I also have a triangle. This here is a triangle. When I look at this, it's upside down, but it's a triangle. So my 11 is my height right here, because it's just showing me on the outside of the triangle, but that's my height. So to find the triangle, it's half BH. That means half times 9 times 11. And when I do that math, I wind up with 49.5. And again, this and this need to get added together. And when I do that for the area, and that makes the area be 81.2925. And it is centimeters squared. Okay, there's my area. And they also want me to find the perimeter. So to find the perimeter of this, I have to go around the outside. Well, I have one measurement. That's 12. This single hash mark tells me it's the same thing over here with that single hash mark. So that makes this 12. I don't need this. That's got nothing to do with my perimeter at this point. But I do need to know how far it is halfway around the circle. So I need half a diameter. So I'm going to find half of pi d, because remember circumference is pi d. So my diameter is 9. So I'm going to do half times 3.14 times 9. And when I do that math, we wind up with 14.13. So what I did is I wrote it right up here, 14.13. And again, now I'm adding 12, 12, and 14.13 to get my perimeter, which gives me 38.13 centimeters. And that's my perimeter there. Okay, this one, whenever I have a shape like this that doesn't have all my measurements in it, I'm going to go ahead and put all my measurements down all the way around the outside first. So again, using my hash marks to help me, this is a single hash mark, that's 2 inches. That means this one up here is also 2 inches. This is a double hash mark here. That means it's going to match this 3 inches here. So that's 3. Another double hash mark, that's 3. All right, that means the only thing I'm missing now is the top. So I need to look at what equals the top. From here to here, it's 1 inch. That means from up here, that's 1 inch. From here to here, that's 2 inches. That means from there to there, it's 2 inches. From here, it's 3 inches. That means this is 3 inches. So 1 plus 2 plus 3 gives me 6 inches for the top there. Okay, now that I have all my measurements, I'm going to find the area first. And you can find the perimeter first if you wanted to. But what I'm going to do is I'm going to divide my rectangles like this. I'm going to put a line down this and a line down this. So now I have 3 rectangles. Well, this large one here is easy. This is going to be 3 times 4. That makes this here 12. This little one in the middle here, I have to again figure out what's my dotted line here. So if this is 2 inches, that makes, and this is 3 inches over here, that makes this part over here just 1 inch. So 1 times 2 for that makes this 2 inches squared for the rectangle there. And then this is 1 times 3. That makes that 3. So when I add those up, I have 12 plus 3 plus 2. And that's going to give me 17 inches squared for my area. Perimeter now. Remember, all I got to do is walk around the outside to do my perimeter. And I think I've covered up some of my numbers there. So let me erase those. Okay, so to do this, remember the top was 6. So I'm just going to walk around the outside. We also said that this was 2 here, this was 3, and this was 3. So I'm going to walk around the outside. So I have 1 plus 2 plus 2 plus 3 plus 3 plus 4 plus 6 plus 3. When I do all that math and I add it up, I wind up with 24 inches. And that's my perimeter. All right, shaded region. On these kind of problems, remember what we're doing is we have to find both things, but instead of adding them together, it's taking it apart. It's taking something out. In this number 11, I have a circle with a triangle inside. I need to take that triangle out of the problem. So I'm going to find both problems. I'm going to find both areas. So my circle is pi r squared. That means 3.14 times 5 times 5, because if the radius, or excuse me, if the diameter is 10, the radius is 5. When I do that math, I wind up with 54.5. So there's my circle. Now I also have to do the rectangle, excuse me, the triangle. And so here I have my triangle, and that's going to be half BH. So that's going to be half. The base is 10. Oh, I'm sorry, no, it's not 10. I was doing the wrong thing there. That was my diameter. Half of 6 times 8. And I could have done 8 times 6 because it's a right triangle there. So either way works. And when I do that there, I wind up with 24 for my answer for the area there. So again, thinking about what I have to do, I have the circle, I'm taking away the triangle. That means I have 54.5 minus 24. And when I do the math, we wind up with 54.5. Sorry, I actually wrote the wrong thing in here. Let me go back. This right here, okay, when I do this right here, the math for the circle actually comes out to 78.5, sorry. That's my math for the circle. And then we have 24 for the triangle. When I do the math now, we have 78.5 minus the 24 gives me my actual shaded area of 24.5 meters squared. So this is this answer. Okay, then we also have this one here. This one we're going to start with a rectangle. We're going to subtract, excuse me, we're going to subtract the semicircle from this. But we have the area is equal to length times width. That means 9 times 7. And 9 times 7 is 63. And then we have the circle, but we only need half of a circle. So again, it's going to be half pi r squared. I'm kind of altering my formula a little bit. So that means 3.14 times 4.5 times 4.5 sorry, not 4.5, 3.5, because half of 7 is 3.5. And again, we're going to divide it in half when we do this. So when we do that math, we wind up with 19.2325. And again, I'm taking the 63 and I'm minusing this. And so my shaded area becomes 43.7675. And we have centimeters, centimeters squared. There is my surface area. Oops. Okay, on this one here, we have a, we're determining the shape, and then also we're going to, from the net, and then we're going to use that to find the volume in the surface there, or the surface area, depending on what they're asking for. So on this one, clearly that's going to fold up to become a cylinder. So there's my shape. This is a cylinder, because we have 2 circles on this would be the bottom, this would be the top, and then this would be the label, so to speak, around it as we do it. And we're trying to find volume. Okay, so volume of a cylinder is equal to the area of the base Did that on the first page, times the height. So the volume is equal to 3.14 times 7 times 7 times 19, because that's the height of my label. Oops, I didn't need to circle that yet. And then when I do all that math, I wind up with 2923.34 meters cubed. This is my volume of that cylinder. Over here, when I fold this, this is actually going to become a cube. It is not a square prism. Be careful. You really should call it a cube. That is the more accurate thing. It's also not a rectangular prism because all these sides are going to be the same. When you fold all this up, this winds up being 15 on everything when you go through and fold it all up. So the surface area, this time we're doing surface area. And this is also why I tell you to kind of think of it as a flat shape when you're doing surface area. I'm going to find one part of this, and then I'm going to times it by 6 because they're all the same. So that's 15 by 15, and 15 times 15 is 225. And I'm going to times it by 6 because there's 6 of them, and so I wind up with 1350. And this is feet squared because this is area again. All right, what is the height of a cylinder with a volume of 997 feet cubed and a diameter of 8.4 feet? Round your answer to the nearest whole number. Okay, the hardest part about this one here is the fact that we have to find the height. They're not giving us the height. They give us the volume. So we're going to write out our formula first. Always start with a formula. Volume of a cylinder, again, is the area of the base times the height. All right, so that means V I have. V is 997. Okay, so I'm going to put 997 here for V. The area of the base is pi r squared. Okay, so that's pi, 3.14. The radius, okay, if the diameter is 8.4, the radius is 4.2. So that makes my pi r is 4.2 times 4.2 times the height of the cylinder, which is what I'm trying to find out. So this is my h. If you don't like to use h as a variable, you can use a different variable. That's okay. Now I'm going to do the math. So when I do the math, I wind up with 997, and I'm going to multiply all this. And I get 55.3896, but I still have to multiply it by h. Okay, now this is an algebra problem. The only thing is the numbers are rather large, but don't worry about it. It's just like if I was saying something like this, like if I said 10 is equal to 5x. We already know that looks the exact same thing. It's just bigger numbers. So I know to do this one, I would just divide by 5 on both sides, and I would get that x is equal to 2. All right, so I'm going to do the same thing. I'm going to divide both sides by this big, long decimal number, 55.3896. We know that's going to cancel out. And I got to do it over here too. 55.3896. Okay, so I'm left with h over here. That's what I want. And h is going to wind up equaling 17.99, and it said something, something, something. I don't know. But I didn't really care about the rest of it because I know that they wanted me to round it to the nearest whole number right here. I'm watching my directions. So I'm going to round it, and I wind up with 18 is equal to the height. And actually, that's 18 feet. That's what we're looking for, feet. So that is the height of my cylinder there. Number 16, a rectangular prism has dimensions of 2 centimeters long, 4 centimeters wide, and 9 centimeters high. If its length is increased by a scale factor of 5, what will be the volume of the new prism? The only thing you need to tell me is, well, now we're going to actually change the one thing. So the length. This is the length here. It's a scale factor of 5. That means 2 times 5. And that gives me 10 now for that. So we know that volume of a rectangular prism is the area of the base times the height, which works out to be length times width times height. And then that's going to be 10 times 4 times 9. And when I do that, I wind up with 360 meters cubed. So that's all there is to that one. Remember, though, that since that the one thing was a scale factor of 5, that means my volume increased by a scale factor of 5 as well. If the volume of a new prism is 12 times larger than its original volume, then the new height of the prism is, And this is what I just said. It's also 12 times larger. Because remember, one thing is going to get changed. If one thing changes, like the length or the width or the height, then that makes my entire volume change by the same thing. When we're talking volume, it does not hold true for surface area. Okay, this is asking me about a can of Pringles. Is 30 centimeters tall, diameter of 6 centimeters. How much space is inside the can? All right, diameter 6, that means R is equal to 3. Space inside the can, I have to know that that is a volume question. So, and it's a cylinder, so it's going to be the area of the base, which is pi r squared, times the height of the Pringles can. So volume is equal to 3.14. The radius we just said is 3 times 3 again. Remember, best to write it out like this instead of writing 3 squared. And the height is 30. Because now that I have it written like this, all I got to do is type all that in the calculator. And when I type all that in the calculator, I wind up with 847.8 centimeters cubed. Because again, volume. So don't forget, volume is going to be cubed. All right, this one is asking about what happens to the surface area. So we actually have two problems to do. A box of snack crackers has the dimensions of 4 by 4 centimeters wide, 15 centimeters long, and 20 centimeters tall. How much larger is the surface area of a new box if the width is doubled? All right, so I'm actually going to work out both of these. So the first one is just going to be volume is equal to length times width times height. Oh, I'm sorry, not volume, surface area. Excuse me. So surface area, remember when I do surface area, I'm going to do top and bottom. The top and bottom was 4 times 15, which is going to equal 60. And I got to times it by 2 because I have a top and a bottom, and that gives me 120. My front and back is going to wind up being 4 times 20, which is going to be 80, times 2 gives me 160. And then my side and side on this first one is going to be 15 times 20. And that's going to equal 300 times 2. And that's going to give me 600. All right, when I add all these up to get my surface area, I wind up with 880. And what are we doing here? This is centimeters squared. Okay, so this is my original surface area. Now, I need to find out how much larger is it if the width is doubled. So now instead of 4, I'm going to use 8. So what I'm going to do is really, literally, wherever I see a 4 in my problem here, I'm going to put an 8. So my top and my bottom become 8 times 15, which is 120. Again, times 2 gives me 240. Oops. Okay, times 2 equals 240. Sorry, a little glitch on the computer here. Then I have the front and back. And again, I'm going to change the 4 to an 8, so it's 8 times 20. And I get 160 times 2 gives me 320. And then I have side and side. Now, this is going to be the same. This is still going to be 15 times 20, which is going to be 300. Times 2, which gives me 600. And again, I'm going to add all those up, and now I get 1160 centimeters squared. This is my new volume, or excuse me, my new surface area. So you can see that when you try to do the math, it doesn't, just because we increased the, we doubled the width, it doesn't double my volume. It doesn't have the same correlation as volume does when we do that. So this is all I need to do for my work on that. All right, a cube has a length of 4 inches. What's its surface area and volume? Okay, surface area, just like the cube we did a minute ago when it was all stretched out, this is 4 by 4. So we have 4 times 4 equals 16. And we need to times this by 6 because we have 6 of the exact same squares. And that would be all of my surface area. And so when I do that, I wind up with 96 inches squared. This is my surface area. And then I need the volume. Okay, volume is going to be easy because we know it's the area of the base times the height, which mainly means length times width times height. And then it's just going to be 4 times 4 times 4. And when I do that math, I wind up with 64 inches cubed for my volume. So that one's pretty simple there. And that's it. That's the end of our review. Please make sure that you come to class with any questions you have for me, and I will be happy to go over anything. Remember, you can also email me. Study hard, and good luck on your test.